Okay, we're going to do the 2018 paper, and we're going to do the last question B about Penny and her pattern and so on that she's doing. So the very first thing is we've got to complete the table, which is what we would normally do anyway. So they've done a few of the patterns for us. We just have to finish it off. So we would put 20, 30, and 42. So we can start to see the pattern here is 4, and then 6, and then 8. Nobody's really having troubles with this part. That's 8, and then 10, 12. Now we can see that when we're doing a table and we've got to figure out what the pattern is. So we've got either a linear pattern, we've got a quadratic pattern, or we've got an exponential pattern. Well, this is definitely not linear because it's not constant. So the first difference is 4, 6, 8, 10, 12, so that's not constant. So if we do the second difference, we see that the second difference is a constant of 2. And we should know that immediately tells us that we have a quadratic pattern. All right, now we might not get the equation from that at that point, but we know that we have a quadratic pattern. Now, if you know anything about quadratic patterns and about the second difference, which is what this 2 is, we know that the very first term is going to be, well, it's n as opposed to x, but it's going to be n squared, right? So that means that if we take this term and we square it, we're going to get 1, and then we add 1 onto that. We square it, and then we're going to add 2 onto that. And we square it, and we're going to add 3 onto that. So the pattern is basically this, n squared plus n. Now, if you couldn't get that from the table, that's okay, because we can get it with our graphing calculator. So if you bring up your graphing calculator and you go into a menu and you go to Stat, and you throw 3 points, 3 or 4 points is all you need. So if I go 1, 2, 2, why are you giving me an error? Come on. Play. No, I don't want you to do that. Exit. Two, 3, 4 if you want. Don't need 4, but we can do 4. And then we go over and we go, okay, what's the y value, which is 2, 6, 12, 20. Now, go to Calc, go to Regression. I know it's a polynomial, I know it's x squared, so I use F1, and there it is. Now, it's in this form of ax squared plus bx plus c, but a is 1, so you've got x squared, and b is 1 plus x, and you don't have any c. So it's using x's, but you can use n's. These are the same equation, right? So the rule for calculating t to the n is either n squared plus n, but if you like x's, you can go x squared plus n. All right, so t to the n is equal to, that's the equation. It's as simple as that, throwing into your calculator. Now, you want to use that rule to calculate the pattern when the number would have 156 tiles. So we basically want this to be 156. We want to solve that. Now, there's a couple of ways to do it. You can do it by hand. You could try to throw it into the calculator and get the parabola up. So there's a couple of ways that we could do this. The easiest thing is if you're going to use a calculator. There's 2 ways to use the calculator for this if you don't want to do it by hand. All right, you can certainly do it by hand. If you're going to do it by hand, you've got to make the 156 come over. So you're going to minus it to the side and make the whole thing equal 0. And then you're going to factor it out and do it by hand, which is not particularly difficult. But if you're not very good at the algebra, you could do it with a calculator. Now, with the calculator, the easiest thing to do is go to your menu, go to your graph function, throw the n squared, which is basically x squared plus x. All right, draw it. There it is. That's the quadratic. Now, when is x so that this whole thing equals? So there's a number of ways that you could do it. You could try GSolve. GSolve isn't going to work, unfortunately, when y is 156 because it's too far up and the graph isn't going to show that. Not found. All right. So you would have to go to your window in order to do this and make your y value go as high as 156. Now it's going to look weird, but now you can use GSolve for 156. We should be able to find it. Nope, didn't find it still. So you can see that this is not necessarily the best way to do this. All right, the other option here, if I go back to my window and just go shift window, just go back to standard so I can draw that. There it is. The other option is to go into your menu and put 156 down in the other as another equation. So basically y is equal to 156. So you can do y is equal to n squared plus n, and you can also do this, which is this side of the equation. This is another strategy for doing it, and then draw. Now you'll see, oh my God, it doesn't show anything. So what you have to do is you got to go to your zoom function and zoom auto, starting to work. So you're going to have to play with your zoom function until you can see the point of intersection. You can see that that line, that's the 156 line, and you can see that it cuts the parabola in two places, here and here. So you would go Shift GSolve, and I want intersection points. So it intersects at -13, and it intersects at 12. That's the solution for that. That's one way of doing it. Another way of doing it with your calculator is to go into an entirely different menu. Go to the equation menu, and we're going to solve the polynomial, which is basically, we're going to solve this polynomial here, which is the n squared plus n minus 156 is equal to 0. We have to have it in that form, and we can solve it. So what do? We go into the menu, we go into equation, we go to polynomial, which is F2, because this is a x squared polynomial of degree 2, and the numbers, this is your A, the number in front of here, this is your B, the number in front of N, and this is your C. So ax squared plus bx plus c is equal to 0. So n squared plus n minus 156 is equal to 0. So number in front is A, number in front is B, and that number there is C. So what we do is we have, there's no number in front of the n squared, that's just understood to be 1. There's no number in front of the n, that's understood to be 1. And the C is the negative, and we use negative 156. And we ask it to solve. And there it is. It's just solved it for us. So that is a way of using the calculator. There's a number of ways that you could do it, but when you're trying to solve a polynomial and you're not comfortable doing it by hand, you can use the solver function on your calculator.